This first part is my baseline testing before I touch the tune. These are 3 different short flights, all on the same battery, running stock Betaflight PID and filter settings. The goal here was not to make the quad faster, sharper, or more locked in yet. I was only making sure the build was stable, safe, and flying normally before changing anything in the PID loop. I did make normal Betaflight setup changes for the hardware on the quad, like the VTX, camera, antennas, GoPro, receiver, and basic setup. But none of that was meant to change motor efficiency, PID performance, or how the flight controller was correcting the drone. After this baseline flight, I ran the log through AeroTune and cross-referenced it with the graphs instead of just guessing by feel. That is what led to the bigger first tuning pass in the next section. The point of this baseline was simple. Fly stock first, make sure the quad is healthy, look at the data, then make controlled PID changes instead of just throwing random numbers at it. This second section is the first real AeroTune tuning pass after checking the stock baseline log and comparing it with the graphs. This was the bigger PID change. The goal was to make the quad feel more locked in, add damping, and clean up bounce-back and prop wash without guessing. On roll, P went down 3%, D went up 7%, D max went up 9%, and feed forward went down 4%. On pitch, P went down 5%, D went up 9%, D max went up 11%, and feed forward went down 5%. I term stayed unchanged, and yaw was left alone because yaw was not the main issue. For filtering, dynamic notch was the safer path. RPM filtering can be usable when everything is working right, but in my case, it was causing failsafes. This last section is the final lock-in pass after testing that bigger AeroTune change. After every flight, I was checking the motors by feel, not just trusting the tune blindly. After the bigger D change, the motors were getting hot, so that told me we were pushing it a little too far. Instead of ignoring that, we pulled D back by 2% and flew it again. After that change, the motors went from hot to warm after the flight, which is exactly what I wanted to see. That helped keep the extra damping without overworking the motors or adding too much noise. More D can help with bounce-back and prop wash, but too much D can heat motors and make the quad feel harsh. So this final flight is the cleaner version of the tune. Stock Betaflight first, bigger data-based AeroTune change second, then a 2% D reduction to lock it in safer. That is the whole point for me. Use the logs, check the graphs, feel the motors, fly the same kind of test, and make controlled changes instead of guessing. If you like FPV tuning content, hit subscribe and drop a like. Also check out the Patreon if you want to support AeroTune, the Blackbox log analyzer I've been building to help pilots tune their own quads. You can try it at aerotune.onrender.com and join the Discord link in the description to share logs, test updates, and help improve it. Also using text-to-speech, because it sounds better for voiceovers for now.